Hi everybody, welcome back. Today we're just going to do a little bit of practice with balancing equations. So balancing equations is really about trial and error and counting. Remember, the only thing you can do to balance an equation is add, change, or remove a coefficient. Coefficients are the big numbers that come in front of formulas. So I think it's easiest to walk you through this by doing several examples, and then we'll do more practice with this on Monday when we come back from the weekend. So in your notes in section 4, there's an equation. What I recommend you do, since we are concerned with ensuring that the number of atoms of magnesium we have before the reaction are the same as the number of atoms we have of magnesium and every other element for that matter after the reaction, you should draw a wall that separates the before and after of the equation. And what separates the before and after of the equation is the arrow that runs down the center. So you're going to want to draw a wall first. Then go to the left of the arrow and list the elements. Remember, every capital letter is a new element. So we have magnesium, we have hydrogen, and this is a dash, not a negative, and we have Cl. That's Cl, not capital C, capital I. Now we count how many atoms of our magnesium are there. Remember, the total number of atoms is the coefficient times the subscript. If you notice, magnesium does not have a coefficient, nor does it have a subscript, so they're ones. So there's one atom of magnesium, one atom of hydrogen, and one atom of chlorine on the left side of the arrow. Now go to the right and copy that list in the same order. Mg, H, Cl, and count on this side. What is the subscript for magnesium? There isn't one, so it's a 1. Remember, the 2 here only goes for the chlorine. So there are 2 atoms of chlorine, and there are 2 atoms of hydrogen. So what you can see is that matter was created. We had 1 atom of hydrogen, now we have 2. That cannot be. According to the law of conservation of mass, matter is neither created nor is it destroyed. So this equation is not balanced. It violates the law of conservation of mass. We need to balance it. Again, the only thing we could do is add or change a coefficient, which is the big number in front of the formulas in this equation. So pick somebody that's not balanced that would be easy to make balanced. There's 2 hydrogens on the right. The question becomes, how could we get 2 hydrogens on the left? And all we're allowed to do is put a number here, right? So remember, the total number of atoms is the coefficient times the subscript. What times 1 will give you 2? 2. So if you put a 2 here, 2 times 1 hydrogen will give you 2 hydrogens, which is what you wanted. You fixed your hydrogen. And remember, the coefficient gets distributed to everybody in the formula. So you used to have 1 chlorine. 2 times 1 will give you 2. And now, as you look left to right, you can see that we have balanced the equation. We are not, or are no longer violating the law of conservation of mass. That's all you do. That's all there is to it. And if it doesn't work, you erase and you try something else. Okay? Now, as we go through, I'll show you some tips and strategies to help you balance. Let's go to the next one. Oops. Here's your next one. Again, draw a wall where your arrow is, list and count. Every capital letter is a new element. So how many atoms of aluminum are there here? 2 and oxygen 3. Aluminum 1, oxygen 2. So pick somebody that's not balanced that would be easy to balance. If there's 2 aluminums over here, I could get 2 aluminums over here by putting a 2 in front of aluminum. 2 times 1 gives me 2 aluminums. Now we're kind of stuck. There's 3 oxygens over here and only 2 oxygens over here. So what number can you multiply 2 by to give you 3? Right now it's a 1. Obviously, y'all probably know if you put a 2 there, 2 times 2 would give you 4. And that's too many. But what you could put there instead of a 1 or a 2 is a 1.5, right? 1.5 times 2 would give you 3. And then if you notice, everybody's balanced. However, you cannot have 1.5 molecules of oxygen. That's impossible. So if you balance using a half, like I did here, you have to get rid of it. You have to take all the coefficients in the equation and multiply them by 2 to get rid of the half. So that would be 2Al2O3 goes to make 4Al plus 3O2. And now, just so that you can see that it's balanced, you don't have to redo this, but notice your ALs, there's 4 of, your O's, 2 times 3 would give you 6, your ALs, there's 4 of, and 2 times 3 for your oxygens will give you 6. And now you can see that we're balanced. When you balance, you always want to use whole numbers. So if you use a decimal like I did to balance it, you have to get rid of it. And you always want to use the lowest possible numbers to balance, okay? It's called the simplest coefficients. Let's take a look at the next one. Draw a wall, list, and count. Copy that in the same order over here. Carbon is 1, hydrogen is 2. Oxygen is unique because oxygen is in 2 compounds on this side. We want to list those separately. So we want to say there are 2 oxygens in the first compound plus there is 1 oxygen, have a good weekend, William, in the second compound for a total on this side of 3. Oxygen is what I would refer to as funky because it's in more than 1 compound on the same side of the equation. Never, ever start there. Balance that guy last. Usually if you balance everybody else, the funky will work itself out, okay? So let's pick somebody that's not balanced and make them balanced. I'll use a different color here because it's a little bit easier. So, somebody that's going to be easy, not the funky. Save them for last. Let's start with carbons. You have 2 on this side. Go to the side with less. How could you get 2 here? You would need to put a 2 in front of the CO2, right? Now, before we move on, make the changes. You used to have 1 carbon. 2 times 1 carbon will give you 2. And in the first compound, you used to have 2 oxygens. 2 times 2 will give you 4. 4 oxygens there plus the 1 oxygen there give you a total of 5. Notice, you have to be focused, you can't be distracted, otherwise you're going to make mistakes. All right, carbons are balanced, I fixed them. Hydrogens are not. I have 6 over here, but only 2 here. What can you multiply the 2 by to give you 6? Obviously, hopefully, obviously, a 3. 3 times 2 gives you 6 hydrogens. 3 times 1 oxygen gives you, 3 times 1 is 3. 4 there in the first plus 3 in the second give you a total now of 7. So we go over here and we have 2. All right. So if I put a 2 here, that's going to give me 4. That's not enough. If I put a 3 here, that's going to give me 6. That's not enough. If I put a 4 here, that's going to give me 8. That's too much. So go in between the 3 and the 4 and give yourself a 3.5. 3.5 times 2 will give you what you're looking for, which is 7. Okay? Now, again, just like up here, you can't leave the half. You have to multiply all the coefficients by 2, even this one. So this is a 1. 1 times 2 would give you 2. This becomes 7. This becomes 4. And this becomes 6. You multiply all the coefficients by 2. We'll do one more for this video, and then we'll kind of save the rest for later. Draw a wall, list, and count. S-E-O, S-E-O. I'll show you another method that I use sometimes. 1 S-E, 2 O's, 1 S-E, 3 O's. If you don't like to use decimals, you don't have to, even though we could put a 1.5 here and then multiply everybody by 2. You can think for your oxygens about least common multiple. So what's the least common multiple of 3 and 2? 6. So you can make 6 oxygens on this side and 6 oxygens on this side. If we want to make 6 oxygens, we need a 2 here. 2 times 1 Se gives me 2. And you might go, oh no, your SEs were balanced and you messed them up. That's okay, we can fix them. 2 times 3 oxygens gives me 6. Let's go over here and fix our SEs. 2 times 1 gives me 2. And if we have 6 oxygens on this side, we need 6 here. We put a 3 here. 3 times 2 gives us 6. So instead of doing the decimal where we multiply, you can always think of least common multiple. I'd like you to try one, just for practice. You have this one here. Why don't you try to balance this one for Monday, okay? Draw your wall, list and count, see if you can come up with the right balanced equation. And that would be it, everybody. We'll see you on Monday. Bye-bye.